Hi there, Addie. Welcome to lesson number 26, and we are going to be talking about more complicated equations today. I think you're going to like it. These are just as satisfying as the ones we've already been doing, but maybe even more because they start out really, really complicated, and then we're going to solve it down to x is equal to something, and that feels good. You got to you're going to love it. You're going to love it. First of all, I asked Zach again to help me with a meme, so this is the one he gave me. I'm sorry, when short people see someone shorter than them. That's so true. I do that. Do you do that? Not that you're short or anything. You're perfect. Anyway, all right, let's jump into, guess what? This lesson just starts with examples. So it's kind of awesome. We've been solving equations already that have variables like this on one side of the equation, and then this might be equal to 7 or something, but now we're going to do more complicated equations that have variables on both sides of the equation. So that can make it a little trickier. So when this happens, the first thing that we're going to do is we try to get the variable by itself. Whoops, I didn't mean to do that. Try to isolate the variable on one side of the equation. It sounds like a mean thing to do to the variable. Let's isolate the variable. But that's what we're going to do, because in the end, we want x is equal to something, and we want to know the answer. And it doesn't matter really which side we choose. I like it on the left-hand side because then it says x is equal to something, but it totally doesn't matter. You can do whatever is easiest. So we're just going to do some examples, and I think you'll get the idea. These are more complicated examples. That's why this little picture there, I think it was supposed to be a GIF. I don't know. Why'd you have to go and make things so complicated? Anyway, yeah, you're going to feel like that with some of these, but we'll figure it out together. Okay, so let's say that we are starting with something like this, and in the end, I want it to be x is equal to something. So the first thing that I'm going to do is I'm going to get rid of the variable on this side of the equation. I don't like that there. I want to combine it with this. And I can combine it because these are like terms. See, now everything that we've learned in the past has a good use, because you have to know what is a like term. And the variables are the same, so we can just put them together. All right, so check it out. This is how we're going to do it. We're going to subtract 5x from this side, and that will turn that to 0 on that side, right? But we got to do the same thing to both sides of the equation. Of course, it's like a teeter-totter. You have to even it out. Okay, so on this side, on the right-hand side of the equation, if I do this, that simplifies down to 0, right? It would just be 0 plus 7, but I don't even want the 0 there, so I'm just going to do 7. Okay, I'm going to bring down my equal sign, I think, if I can do this properly. And then let's start working on the left-hand side. So 3x minus 5x is negative 2x. And then this one, I didn't do anything to that, so I'm just going to bring it down. So negative 2x minus 4 is equal to 7. That's what we're left with. And that's easy because that's like the ones we've been doing so far, right? So now let me get a different color so you can see what I'm doing. I'll make it fatter. Okay, so I'm going to add 4 to both sides of the equation because I still want to isolate that variable. So that's what I'm trying to do. So I'm going to bring down negative 2x because I didn't do anything there. This cancels out to 0, is equal to, and then 7 plus 4 is 11. Okay, now I still need to get that variable by itself. So I'm going to get another color. I'm going to divide this by negative 2 and divide this by negative 2. So those 2's cancel out, and of course the negatives cancel out. So I'm left with x is equal to negative 11 over 2. And that is the final answer, right? That's pretty cool. I love these. I love these. I hope you're not too looking like this idiot right here. He looks a little confused, and he probably is. He doesn't know where he is, but if you're confused, it's not because you don't know where you are. It's because this one looks a little bit more complicated, right? So let's figure it out. This time, just to show you that we can do it this way, we're going to get the x on the right-hand side of the equation. Okay, so how would I do that? I'm going to subtract 3x from both sides. Okay, so I'm on both sides of that equal sign, right? Okay, so now this first 3x, that just cancels out. So I don't need to worry about that. So I bring down that minus 4 is equal to, and I've got to add these together. 5x minus 3x is 2x. 2x plus 7. All right. I still want the x by itself, even if it's over on that right-hand side of the equation. I still want to isolate it. So I'm going to get rid of that 7 next. Minus 7. Because basically these are like terms, right? The 7 and the 4, because there's no variable with them. So they're basically like terms. All right, so when I do that, these 7's right here, they just cancel out because it's 7 minus 7 is 0. But over here, I have negative 4 minus 7, so it's, or plus a negative 7. So that's equal to negative 11 equals 2x. Let's divide by 2, and those cancel out. I'm just going to erase it. And I have x is equal to negative 11 over 2. And guess what I just realized? I didn't even realize this. This is the same exact problem as the one before. They just showed you 2 ways to solve it. Oh my goodness. I just showed you 2 ways to solve it. So this just goes to show that you can put the x on either side. You'll get the same answer. This is the same thing. Negative 11 over 2 is equal to x. Bam. All right, so what if it gets a little bit more complicated? You still got this, girl. Okay, let's try it. The first thing that I'm going to do is I'm going to add like terms. And if they're on the same side of the equation, it's super easy to do, right? So I can add 4 and 2, right? So if I add these things, then that's going to be positive 6. Okay, so I took care of those. And look, these are also like terms, the negative x and the 3x. Why are they like terms? Because they have the same variable, an x and an x, and this is basically a 1, so minus 1x. So if I do, let me just erase these because I already took care of them. Wait, is that a good way to do it? I don't know. Let me get a different color. Okay, so I'm dealing with this and this, 3x minus x. 3x minus 1x is just 2x, so I'm going to put that there. 2x plus 6 on the left. Now, let's do the same thing on the right. We're just adding like terms. So we're just kind of simplifying it. So we have a minus 5 and a minus 4. So if we add those together, negative 5 plus negative 4, that's going to be negative 9. Okay, so I took care of those. And I'm just left with this minus x over here. So I'm just going to bring that down. Okay, so now that whole big old complicated equation boiled down to this guy. That's not so bad, right? That's not bad at all. All right, so do I want the x on the left or the right? It doesn't even matter. Let's add it. Let's get the variable on one side. So I'm going to add an x here, and I'm going to add an x here. Okay. You can do the same thing. It doesn't even matter that it's a variable. You can add it to the equation as long as you do it to both sides, right? All right, so this whole side over here, this cancels out. The negative x plus x, that's going to be 0. But over here on the left, we have 2x plus 1x, and that's going to be 3x. And then I'm just going to bring down that 6. 3x plus 6 is equal to negative 9, and those canceled out. All right, easy peasy. Let's subtract a 6 from both sides. That is next step right there. And of course, these just cancel out to 0. And what about negative 9 minus 6? Negative 9 minus 6, or negative 9 plus a negative 6, is going to be negative 15. Okay, and since those canceled out, I just have 3x over here. Last step. Let's isolate that variable. Okay, and these 3's cancel out. So then I'm left with x is equal to negative 15 over 3. But you can simplify that because 15 actually can divide by 3 and you get negative 5. So now x is equal to negative 5. Easy. Beautiful. Hi, Addie. You want to say hi to future Addie?
Hi.
Hi, future Addie. Okay. All right, next example. This is example 26.4. We are going to solve this really complicated thing. And let's go through it and see if we can combine any like terms and make it look a little easier. Here are just some numbers we can combine. So plus 3 plus 7. Let's see. I'm going to make that plus 10 on the left. Okay. And also these combine, because look, there's just a k. So 1k minus 4k, 1 minus 4 is negative 3. So it's going to be negative 3k plus 10 on the left. All right, on the right-hand side of the equation, it looks like there's nothing I can combine because those are not like terms. So I'm just going to bring it down the way it is. 2k minus 5. All right, let's see. You know what? Let's get, what are we going to do next? Let's add, why don't we do this? Why don't we add the 5 to both sides of the equation? Let's get rid of that 5, plus 5. Everything else, I'm just going to bring it down. So minus 3k plus 15 equals 2k, and those 5's cancel out. Okay? All right, sweet. Now I'm just going to erase some of this so that I have more room to do the problem, and you can see it. Okay? We're not done yet. We are not done yet. You know what? Let's take this 3k and bring it to that, because these are like terms. We can add them together, and I also want to isolate the variable, so I'm going to start combining those. All right, let's do it. We're going to add 3k, add 3k. If you don't do it in the exact same order that I'm doing it in, you'll probably still get the same answer as long as you're following the rules, okay? So on the left-hand side, we're left with 15 is equal to 5k. And we're going to divide by 5, and these 5's cancel out. So I'm left with k is equal to 15 divided by 5. Of course, that can simplify. 15 divided by 5 is just 3. So k is equal to 3. Bam, that was easy. All right, now you're going to want to be able to do these problems so that you can be a nerd and, you know, just fit in with these guys. If you want to do something complicated like that, you're going to have to know how to solve these problems. So let's do the next problem, 26.5. And we are starting with something pretty complicated looking, but you know what? It's not going to be that bad because we can combine like terms, and I see 2 right there. All right, let's start doing it. Negative 7n plus 2n. Negative 7 plus 2 is going to be negative 5n. Okay, and then I don't see anything else on the left-hand side of the equation because the equal sign is there. So I'm just going to bring down that plus 3. Okay, now let's focus on the right-hand side of the equation. Are there any like terms we can combine? Yeah, there's a 4n, and there's a regular n, which is a 1n. So 4n plus 1n is 5n. And then I'm left with just this negative 5, so let's bring that down. Alrighty, let's do this. Okay, just from the looks of this, well, should I do it the way they did it in the book? Yeah, I'll do it the way they did it in the book. Okay, just to be consistent here. What they did next is they subtracted 5n from both sides, I think. Okay. Alrighty, so then when I do this part, negative 5n minus 5n, it's going to be negative 10n. Let's just bring down that 3. Plus 3 is equal to, this whole thing cancels out, negative 5. Okay, let's start erasing. I need some more room for these complicated equations, right? This is getting quite complex. So I'm going to move that up just so you can see it. I have more room. Okay, now next step. I still want to isolate that variable, get that n all by itself. So I'm going to subtract 3 from both sides. And I have everything else I'm just going to bring down, right? So I'm going to bring down negative 10n. That's 0 is equal to negative 5 minus 3 is going to be negative 8. And then if I subtract both sides, minus 10 by minus 10, then these cancel out. the minus 10 over minus 10. So I have n is just equal to negative 8 over negative 10. Now, when you divide a negative by a negative, you get a positive. So you can basically just cancel out those negatives, and n is equal to 8 over 10. But don't forget, that can simplify, and you got to simplify these. So both of those numbers can be divided by 2. So if I do that, 8 divided by 2 is 4, 10 divided by 2 is 5. All right, so let's review what the rules are. If you had to tell someone how you're doing these problems, I mean, for me, since I've done like a bajillion of these types of problems, it comes naturally. I don't even have to think about it anymore. And that's how it's going to be for you once you're all done with this. Step 1 is to add the like terms. So look on the left-hand side of the equal sign, look on the right-hand side, add anything that's the same. It's just kind of simplifying. Step 2 is eliminate the variable on one side. Okay, so if you have an x on the left and an x on the right, try and get rid of one of those x's so that you're going to end up with x is equal to something, okay? Step 3, eliminate the constant term on the side with the variable. So that means if you have like 3x is equal to something, what you're trying to get rid of last is that 3, because that's the constant that's on the side with the variable. And step number 4, you just do the math and solve for the variable. All right, let's do it one more time just to make sure we've got those steps down. You're like, no, you're not. You've got this. All right, here's the problem. Woo, this is complicated looking, right? But we are going to try and solve it here. Step 1 is going to be adding like terms. So this is a like term with this. All right, so 2x plus 7x is going to be 9x, and I got rid of those. All right, and then I have to deal with that negative 5, and there's nothing I can combine it with on the left, so I'm just going to bring it down. Okay, what about on the right-hand side of the equal sign? What is a like term? Well, this is and this is, because there's no variable with it, right? So 3x, I just brought down that 3x, and then I'm just adding 15, because I just did that in my head. I combined those two and got 15. All right, so now we're left with this purple equation, and we can solve something like that, right? No problem. You know what? You can actually do this in multiple steps. Like if you want to, okay, it's a little more complicated, but you're super smart. I bet you can do it. Minus 3x here, minus 3x here. Okay, check this out. I'm not done yet. Let's just go ahead and add the 5 to both sides. Okay, sweet. See what I did there? I just combined a couple steps into one. I don't usually do that, but let's just do it. All right, so we have 9x minus 3x is 6x. These cancel out, right? And then I'm just going left to right. 3x minus 3x, that cancels out to nothing. So I'm just going to bring down the equal sign. And then 15 plus 5 is going to be 20. See what I did there? I did like 2 steps in one. Haha, that's awesome. All right. Last step, I want to eliminate the constant that goes with the variable because I want to isolate the variable. So let's divide both sides by 6. Okay, and then these cancel out, and I'm left with x is equal to 20 over 6, but both of those are even numbers. So if they're both even numbers, I know you can at least divide it by 2. So I'm going to make that 10 over 3 and see if that can reduce further. And I don't think it can. So the answer is x is equal to 10 over 3. That's the simplified answer. And guess what? We are done with this lesson. All right, Addie, have fun doing your homework. And I'll be thinking about you. Let's correct this when I get home, okay? That'll be super fun. All right, love you, Addie. Have a good day. Bye.